Precalculus second mid 9 weeks preview for Common Assessment, and this is going to be for December of 2020. And I'm going to go over, I think, 12 problems here as a preview. Number one, the function g of x graphed below is a cubic function, and that means we're going to have the leading term is going to be x to the power of 3. And what this problem does, it tests the understanding of the fundamental theorem of algebra, which is that the number of zeros, real and non-real, of a polynomial function is equal to the degree of that function, and some of the zeros may be repeated. So we're going to have, by virtue of that theorem, we're going to have 3 total zeros. And it so happens that when we just look at the graph, we can see that one zero is real. And what that means for us is that since there are 3 total zeros and 1 zero is real, the number of non-real zeros is 3 minus 1 equals 2 non-real zeros. And so, based on this graph, which the following statement is true: A, we have 1 real zero and 2 non-real zeros. Fundamental theorem of algebra. Next, problem 2. The table below shows the number of patent applications in certain years starting in 1980. Which type of regression might best model these data? This might help to set a 1980 as a year 0 to more easily analyze the data. And so we're going to just plot the data and see if the data can best be modeled by a sinusoidal curve, something like this, a square root curve that's going to look something like this, a quadratic that's going to be sort of either upward curve or a downward curve, or a type of linear relation. So we're going to look for just the shape to be one of those things, and we're just going to plot and look at it. So to plot this, we're going to go to the calculator and go to stat edit, stat enter, and just enter the values here. I'm going to put 0 for 1980, and then we have 10, 15, 18, 19, 20, 21, 22, 23, and then over on the other side, I'm just going to round to the nearest thousandth. 113, 177, 229, 261, 290, 316, 347, 358, and 367. So that's all entered. I go and make sure the plot is turned on with the function enter. Yes, it is. When I graph, I don't see anything. We have these points here. I'm going to see what they look like by pressing zoom 9, which is zoom stat. And so that the window is set to bring in all the points that are plotted. And it's really, this is not super deterministic here. It doesn't look linear, definitely not a sine or some function or a square root. Probably the quadratic is the best fit for this to model. And so based on that, C is going to be our best answer. Next, 3A, and the next 10 10 problems I'm going to do have an A and a B part. I'm going to do the part A and leave the viewer to do part B, 3B. If f of x and g of x are inverse of each other and f of x equals 2x minus 3, what is g of 5? Well, let's find the inverse of f of x to find what g of x is. So if we put y is equal to 2x minus 3, so these are just the steps of solving for inverse function, and switch x and y, so we have x equals 2y minus 3, and solve for y, add 3, so 2y equals x plus 3, and dividing by 2, we have y is equal to 1/2 x plus 3. And so that's going to be g of x being the inverse of that original function. So g of x equals 1/2 x plus 3, and we're asked what g of 5 is. Well, g of 5 is going to be equal to 1/2 of 5. Well, that's going to be 3 over 2. Oops, there we go. Plus 3 over 2, which is going to be equal to 5/2 plus 3/2 is equal to 8/2 or 4. So g of 5 is equal to 4. And we can test to see if we did the calculations, the algebra properly with the inverse functions by going to our function editor and entering the two functions here. So we have 2x minus 3, and then our calculated inverse of that function, which is going to be 1/2 x plus 3/2, which is 1.5. And we'll see if these are inverses of each other. We graph, really can't see them here. So I'm going to press zoom 6, get a standard window. So we see the red and the blue one. The red function is going to be the inverse we're looking for. Well, also we're going to look for the reflection about the line y equals x, which we see here. And then we go to the table view. We can see for an input of 5, we have an output of 4. So that's going to be our answer here. I invite the viewer to work 3B, so it's a similar type of problem. See if you can do that. Next, 4A, solve the following equation for the unknown x. There are different ways to do this one. One would be algebraically, and one would be more graphically. So for graphically, what I suggest is setting one side of the equation equal to 0. So I'm just going to write down graphically first. And what I'm going to do to set the right side of the equation equal to 0, I'm going to put 3x over x plus 5 plus 1 over x minus 2, and I'm going to subtract what's on the right side there. So I'll put minus 7 over x squared plus 3x minus 10, and set that equal to 0. And when I graph this function and see where the graph touches or crosses the x-axis, that'll be right. So I'm going to go to the function editor again, clear out what we have, and write in the functions here. So I'm going to put first 3x over x plus 5, and then we have plus alpha 1 over x minus 2, and then finally we're going to subtract that other side of the equation. So we're going to have 7 over x squared plus 3x minus 10. And when we we graph this function, we should see where the function crosses the x-axis. So here it looks like between -1 and 0. To find out exactly what that is, we can go to second trace, we can go to 0, which is option 2, and we're asked the question left bound, so we just arrow over here to the left of the x-intercept, press enter, and then we arrow to the right of that x-intercept, press enter again twice, and we get -0.3333, which is, I hope you recognize, as -1/3. So x is equal to -1/3, and so that's graphically. And then you can also do this one algebraically. And what we can do is multiply by something that would clear the denominator. And so if we multiply the whole equation by x squared plus 3x minus 10, we're going to clear out the x plus 5, the x minus 2, and everything. So let's go ahead and do that. So multiply by quantity x plus 5, x minus 2, and we do that, what we get is 3x, I'm just going to write below here, we get 3x over x plus 5 times quantity x plus 5, x minus 2, and then we have plus 1 times quantity x plus 5, x minus 2, and that's going to be over x minus 2, and then we're going to have equals 7, and we multiply this by quantity x plus 5, x times quantity x minus 2, and that's going to be over x squared plus 3x minus 10. And what happens is we're going to clear that denominator here. So we clear that denominator, clear that. So what we have left, we have 3x times x minus 2. So that's going to be 3x squared. And then 3x times minus 2, we're going to have minus 6x. And then plus, we're going to have 1 times x plus 5, so that's going to be x plus 5. And the right side we have equals 7. And we can combine like terms. We have 3x squared, and then we have minus 6x plus 5, so that's going to be minus 5x. And then we're going to have plus 5, well, that's going to be plus 5 and minus 7 from the other side. So we're going to end up with minus 2 equals 0. And if we can factor this, we're going to see that we're going to have our solutions. And we put AC on top, which is negative 2 times 3, or negative 6, and B on the bottom, which is negative 5. So what two numbers multiplied together equal negative 5, but added together equal, two numbers multiplied together equal negative 6, but added together equal negative 5? Well, how about negative 6 and 1? So then if we divide this by 3, we get negative 2. So we're going to have, for our factoring, we're going to have x minus 2, and then we're going to have this x plus 1/3, and using a bottoms up, we can take this 3 times x, so it'll be 3x plus 1. And if we set this equal to 0, we're going to have x is equal to 2, and then we're going to have 3x plus 1 equals 0, and subtracting 1, we're going to have 3x equals negative 1, so x is equal to negative 1/3. So that's our real solution. This x equals 2 is an extraneous solution because if we put 2 back in the original, that won't work. So real, and this x equals 2, that's extraneous. Okay, let's go on to 5. If f of x equals x squared minus 2x plus 5 and g of x equals 2x plus 2, what is f of g of x? So this is a composition of functions. Sometimes you'll see this written as f of g of x instead. So what we're going to do is to find f of g of x, we're going to put g in place of any place we see x in the f. So we're going to put 2x plus 2 here, and also 2x plus 2 in the place of this x. So f of g of x is going to be equal to, I'll put 2x plus 2 squared minus 2 times 2x plus 2 plus 5. And then we simplify everything. We're going to have our answer in a simplified form. So we're going to have 4x squared, which is 2x squared. And then we're going to have 2 times the first term and the last term. So 2x times 2, that's 4x, and that times 2 is 8. So we have 8x, and then plus 2 squared, which is 4. And then we're going to have minus 4x, and then also minus 4. And so the 4 minus 4 will cancel each other. So we're going to get, for this one, 4x squared, and we're going to have left 8x minus 4x, so that's going to be plus 4x. So this is going to be our composition here. And then on 5b, we have g of f of x. So for this one, we're going to have to take that f and plug that back into the g over here. Next, 6a, for the function shown below, list the real zeros and the multiplicity of each zero. We can use the zero factor property. If we set this whole function equal to 0, then we can rewrite this as 0 equals x times quantity x minus 1 squared times quantity x plus 3 times quantity x minus 2 times quantity x plus 4 to the 4th power. So if we set each of these factors equal to 0, we have x is equal to 0, we have x minus 1 is equal to 0, we have x plus 3 is equal to 0, we have x minus 2 is equal to 0, and finally we have x plus 4 is equal to 0. So our zeros are going to be x equals 0, and then solving for x, x is equal to 1, x is equal to negative 3, x is equal to 2, x is equal to negative 4. Now for the multiplicities, how often do these zeros occur? Well, for this x equals 0, that's a multiplicity equal to 1. For x equals 1, we have a squared here, so this 0 is going to be multiplicity equals 2. And then for x equals negative 3, that's to the 1st power, so that's multiplicity is equal to 1. And then for x equals 2, we also have a multiplicity equal to 1. And for x equals negative 4, we have that to the 4th power, so that's going to be a multiplicity equal to 4. So that's going to be our answer to 6a. 6b, a similar problem. 7a, what is the domain of the following rational function? Well, what we're trying to look for in a domain is a domain by default is going to be all real numbers. So we're looking for an exception to that, and the exception is going to occur where our denominator is equal to 0. So if we set our denominator, in this case x squared times quantity x plus 5 equal to 0, we will see what x cannot be. And so that basically cannot equal 0, because we can't divide by 0. So x squared cannot equal 0, therefore x cannot equal 0. And then also x plus 5 cannot equal 0, so x cannot equal -5. And since these are the exclusions to the domain, -5 and 0, we have our domain is going to be in interval notation -infinity, comma, our first discontinuity, so -5, and then union between -5 and 0, and then union, and the last piece is going to be 0 greater than 0 less than infinity, so that's going to be it. And you can take this in the calculator also and see the breaks. So if we go to x squared, so I'll put x squared over x squared times x plus 5. And we graph, we can see our break at -5 but not at 0. But if we go to we can see in the table view that we have a discontinuity also where x equals 0. So anyway, those would be the breaks, and then this is the rewrite in our interval notation. 7b, a similar type of problem. Find the domain of that rational function. 8a, what is the list of possible rational zeros for the function fx equals 2x fourth power minus 3x cubed plus 5x squared plus 9x minus 4? What we're going to have is the possible rational zeros is going to be a plus or minus factors of the constant term. And so what are the factors of 4? 1, 2, and 4 over the factors of the coefficient of the first term, which is going to be 1, is going to be 2, so we have 1 and 2. So we're looking for the combinations here. So I'm going to put our answer as plus or minus 1 over 1, plus or minus 2 over 1, and finally plus or minus 4 over 1. Now we're going to concern ourselves by the over 2. 1, 2, 4, okay. So now we can have 1 over 2, 2 over 2, and 4 over 2. Well, 1 over 2 is 1/2, and 2 over 2 is 1, which we already have, and 4 over 2 is 2, which we already have. So this is going to be our list of possible rational zeros for this function. And then 8b is a similar type of problem. 9a, match the correct degree in positive negative nature with each polynomial function. So the first one I'm looking at here, f of x equals 51 minus 3x. Well, our largest term is going to be this one here, which is negative 3x, and that's 3x to the first power, which makes this negative and odd behaving. So odd negative is going to be this one here. Next, negative x squared plus 30x minus 6. Well, so our largest term is this negative x squared, and then the squared is going to make this thing an even, and it'll be even negative. Next, fx equals 3x squared plus 5x to the fifth. Our leading term is going to be this one here, which is going to be odd positive. So that's what this one is going to look like here. And finally, by process of elimination, this one here is going to have to be even positive. So here's our leading term here. So here's going to be our even positive right here. Okay, and 9b is the same type of problem, but actually asks you to create our own polynomial function based on being an odd degree and is negative. 10a, the function fx equals x to the fourth power minus x cubed minus 13x squared minus 4x plus 16 has real zeros. List each real zero and its multiplicity. Doesn't say how many zeros it has. So what we're going to do is, we know that the number of zeros, real and non-real, and I guess we'd have to assume from the way the problem is worded, we probably have 4 total zeros. So let's go ahead and look at what that is. Okay, I'm looking for it here. Okay, let's go to the calculator and put this in place. So we're going to have, trying to read here, we have x to the fourth minus x cubed. So let's do that. X to the fourth power minus x cubed. And then we're going to have minus 12x squared and minus 4x plus 16. And then if we graph this function, okay, I'm seeing it looks like we have 3 zeros, x equals negative 2, x equals 1, x equals 1, 2, 3, 4. And we can verify looking at the table view. We have a 0 where x equals negative 2 of negative 2, a 0 of 1, and a 0 of 4. So negative 2, 1, and 4. And this 0 here at negative 2 is going to be a double 0. So we'll have x equals negative 2, multiplicity is equal to 2. We're also going to have x is equal to 1. That's multiplicity equal to 1. Finally, we're going to have x is equal to 4. And that's also a multiplicity equal 1. And so when you have a fourth degree function, the total numbers of multiplicities will have to add up to 4. So that's going to be 10a. And then you have 10b, which is a similar type of problem. Just graph that problem, look for zeros, determine which are real zeros and their multiplicities. Next 11, what is the synthetic division setup for the quotient of 2x cubed minus 5x plus 3 and x plus 4? Well, for that, we have to create some kind of a synthetic division bracket, And what we have to do is on the outside put the value of the 0 for this x plus 4. So we're going to put negative 4 out here. And next we're going to put the coefficients of the polynomial. So we're going to put 2 for the x cubes place. And you see we don't have any x squareds here at all. So that means the x squared place is going to be 0. And then we're going to have the x place is going to be negative 5. And then the numbers place is going to be plus 3. And so what you can do is when you have this, you can find the quotient, bring down the 2. So we're going to have this is going to be 2x squared. Negative 4 times 2 is going to be negative 8. So we get negative 8 here. Negative 4 times negative 8 is 32. Negative 5 plus 32 is 27. 27 times negative 4, that's going to be negative, is it 108? And then our remainder is going to be negative 105. And so that would be, our remainder would be, so our answer would be 2x squared minus 8x plus 27 minus 105 over our value of our divisor, which is x plus 4. And yeah, that's 105. Okay, that's number 11a. And then you have 11b, which is similar to 11a. Get the right synthetic division set up. Then we have 12a. What is the quotient of the following expression? Well, I worked out problem 11, so this is going to be very similar. If we create a synthetic division bracket, our 0 is going to be 2, so I'm going to put 2 right here. And then the coefficients of the polynomial, we have 1x squared plus 1x cubed plus 3x squared minus 4x plus 5. So we bring down the 1. So our answer is going to be x squared, as in 1x squared. Then 2 times 1 is 2. 3 plus 2 is 5. So this is going to be the x place. 5x. And then 2 times 5 is 10. Negative 4 plus 10 is 6. 2 times 6 is 12. So we're going to have plus 6. And finally, 5 plus 12 is 17. So we have plus 17 over our divisor, which is x minus 2. And really, that's it. So this is some earlier work that we've covered. And good luck on this, and also the more recent material that we've covered more recently and are going to, in class, review a little more as well. Good luck, and thanks for viewing.